Hello students. Now we are going to discuss about the internet protocol layers, that is IPv4 and IPv6 addressing. So this internet layer is also called as a TCP/IP model, and it is responsible for logical addressing, routing and forwarding your data packets from the source device to the destination device and across your different networks. So the two major protocol for internet is two versions, that is IPv4 and IPv6. So now we will talk about the IPv4, that is fourth version of internet protocol. So in this internet protocol fourth version, it is most widely used protocol for identifying devices on the network. This IPv4 is 32-bit internet protocol that provides logical addressing and routing for the device on the network. So some of the main features of this IPv4 is it is 32-bit address. It supports approximately 4.3 billion unique addresses. The address is written in decimal format. It uses 4 octal, that is 8 bit each, separated by the dots. For example, it is given as 192.168.1.10. So the IPv4 address format is shown here. Then this is one of the example where device is IPv4 address, computer address, then router address and server address is mentioned. So the main advantage of this IPv4 is that it is simple and widely supported. It is easy to configure, compatible with almost all networking devices. The limitation is that addressing space. It is 4.3 billion addresses and require network address translation due to address exhaustion. Then Internet Protocol Layer IPv6 comes into picture, which is a sixth version. So this IPv6 is the latest version of Internet Protocol, developed to overcome the drawbacks of IPv4 addressing limitations. So IPv6 is a 128-bit Internet protocol designed to overcome IPv4 address exhaustion by providing a much larger address space, improved security and more efficient routing. So these are the some important features for IPv6, that is 128-bit address. It supports approximately 3.4 into 10 to the power of 38 addresses, and address is written in hexadecimal format. 8 groups of 4 hexadecimal digits separated by the colons. So this is that format. So this format, IPv6 address format, this can be shortened. How? So leading 0 can be removed and consecutive 0 group can be addressed by using these colons. So the same address can be written like this. Then some of the advantages of IPv6, that huge address space, better routing efficiency, space in IPsec security support. It supports automatic address configuration. Then role of IPv4 and IPv6 in IoT. So in Internet of Things, every smart device need a unique IP address to communicate. So IPv4 is still used many existing IoT system but has limited address availability, whereas IPv6 is preferred for modern IoT because it provides a virtually unlimited number of addresses, allowing billions of sensors, actuators and smart devices to connect directly to internet. One of the example is in a smart home device such as smart light, camera, thermostat and sensors can each have a unique IP address and enabling seamless communication without the address shortage. So this is one of the comparative study with respect to features of IPv4 and IPv6. So with respect to address length, IPv4 is 32-bit whereas IPv6 is 128-bit. The address format for IPv4 is decimal whereas IPv6 is hexadecimal. Addressing size is approximately 4.3 billions in case of IPv4, whereas IPv6 has 3.4 into 10 to the power of 38 address size. When we talk about the header size, so IPv4 has 20 bytes, whereas IPv6 is 40 bytes. In IPv4, security is optional, whereas in IPv6, it is an inbuilt. Then Bluetooth low range over IPv6. So Bluetooth low energy over IPv6 is a communication technology that allows BLE device to use IPv6 for internet connectivity. It also uses the 6 low personal area network adoption layer to compress IPv6 packets, enabling efficient low power communication for IoT devices. When we talk about the architecture of BLE over IPv6, then this is the layer diagram where physical BLE device comes first, then BLE, then 6 low PAN adoption, then IPv6 protocol, and at the last IoT application layer. So these are the some of the features of BLE over IPv6, where the feature extracts network support in BLE over IPv6 both works. Internet connectivity, direct IPv6 communication via 6 low WPN. Addressing, IPv6 address used as compared to BLE. Routing, it supports IP routing. This is one of the example. Then ZigBee over IPv6. ZigBee over IPv6 is a communication technology that enables ZigBee based IoT devices to communicate with using IPv6 address. This is achieved to 6 low WPN adapting layer which compress IPv6 packets so that they can be transmitted efficiently over ZigBee networks. It allows ZigBee device to connect seamlessly to IP-based network and the internet. And this is the architecture of ZigBee over IPv6. So BLE over IPv6 is a communication technology that allows BLE device to use IPv6 for internet connectivity, and it uses 6 low WPN adoption layer to compress IPv6 packets, enabling the efficient low power communication for IoT devices. So again here there is a comparison of traditional ZigBee versus ZigBee over IPv6 with respect to features like addressing, internet connectivity, routing, network standards, and IoT compatibility. So ZigBee over IPv6 is a communication technology that enables ZigBee devices to use IPv6 addressing for internet communication. It uses the 6 low PN adoption layer to compress IPv6 packets and allowing low power ZigBee devices to communicate efficiently over ZigBee network and connect to cloud based on IoT applications. Next layer is your application layer protocol COAP. So a REST COAP proxy bridge is the gap between HTTP based internet and COAP environment, enabling the communication between two protocols. So COAP server manages resources and handle request with its environmental facilities and machine-to-machine communication amongst the various devices like camera and client. This setup allows constrained devices with limited power and low bandwidth to connect and exhaust data security. Next application layer protocol is AMQP. So its feature is wire level protocol, transmits data across the network as a stream of bytes and high compatibility due to open standards. It's flexible and secure. And the application is that initially used for the transaction messaging in financial system and now primarily utilizing IoT applications for communication and data analysis. Thank you.